All right. Pretty simple. Ready? We have constant. We have linear. We have quadratic. We have cubic. And we have square root. Okay? Inside of these parent functions, these are what we call our parent functions. Okay? From the parent functions, we derive all the other functions we're going to be working with. Okay? All the functions we're going to be working with. Okay? Now that's not all the functions that are out there. It's just all the ones we're going to be working with. Okay? There's a commonality with these. F of x is equal to c. Okay? That might look like an E. That's a C. Okay? F of x is equal to x. F of x is equal to x squared. F of x is equal to x cubed. And f of x is equal to x to the 1/2. Okay? So let me show you a little bit about what this means. This is really x to the 1, and this is really c times x to the 0. Okay? Notice I use different colors for those. Right? I use a different color because you don't see the 1. You don't see the x to the 0. X to the 0 is 1. You have to remember, x to the 0 is 1. Right? Anything raised to the 0 power is just 1. So 1 times a number, 1 times 5 is 5, right? 1 times 8 is 8. 1 times negative 2 is negative 2. Okay? Right? So, this is a constant because the only thing you ever see is a number. Right? And the way that these graphs look are all very similar. Okay? So, the way that these graphs look are, this is straight across. This one looks like this. This one looks like this. This one looks like this. And this one looks like this. So what happens here, okay, is that if you notice, this one just gets tilted. Yeah? Okay? So it has a slope. At this point, it has a 0 slope. Right? And now this is a positive slope. Now the parent function is a positive slope. Could it end up with a negative slope? Absolutely. Right? This quadratic just looks like a U, right? Now what happens with this cubic is this U gets pulled down. Okay? So you're just taking this piece right here and pulling it down. And what's happening is on the other side, it's going up to infinity really quickly. But on the negative side, it's going down to negative infinity really quickly. And that's because it's cubed. Right? In other words, 2 times 2 times 2 is 8. Right? 8. But negative 2 times negative 2 times negative 2 is negative 8. Right? And so forth. 5 times 5 times 5 is 125. But negative 5 times negative 5 times negative 5 is negative 125. Okay? In this same aspect, there is a shadow effect here. Okay? And this looks just like this, right? Except it's turned on its side. They just take this piece right here and they turn it this way, right? But what happens here is we're talking about square roots. And when y is negative, that's impossible, yeah? Because you can't take a square root of a negative number. You can't equal a negative number. So this kind of goes away, and what happens is it can't happen, right? There is no negative number when you take the square root. Even if you take a square root of negative 2, right? Or a square root of negative 4 is 4i, right? It's the imaginary I, right? It's the imaginary 4. It's not negative 4, is it? It's 4i. Okay? So this goes away because it can't equal a negative number when you take a square root of something. Okay? So the only thing that's left is the positives. Right? And technically, we can't take the square root of a negative number. We can, but we use what's called the imaginary I. And if we plotted it here, it would look very similar to this. It would be 4i, all the square roots. Right? Square root of 4, negative 4 is 4. It's 2i. The square root of 9 is 3. Negative 9 is 3i. Square root of 16, negative 16 would be negative, or 4i, right? So we'd have 2i, 3i, 4i, and it would be in the imaginary realm, but not in the actual realm. So these are our parent functions. Okay, and we're going to manipulate those. And remember I taught you last week how to manipulate them. Horizontal. What does that mean? When you see horizontal and it relates to a function, what does that mean? X what?
X.
OPP. That's right. Opposite. X's do the opposite in a function. When we're talking about functions, right? The X's do the opposite. Okay? Vertical. Okay? What are we thinking of when we think vertical? We think Y, right? So we think f of x. The whole function is being dealt with. The whole function f of x. Okay? Then what are those words that we would like to hang on to? Right? Stretch. And what's the other one that goes with stretch? Compression. Yeah. So we stretch and we compress. What does stretch and compression relate to mathematically? Yeah. Multiplication. Okay. Then there's shift. And when we use that word, what does it relate to mathematically?
Addition.
That's right. Okay? And then there's up, there's down, there's left, and there's right. And what are they mathematically? Addition and subtraction. Subtraction and addition. Yes. Okay? And with this, we can do anything. We can literally do anything. I'm going to show you the hardest problem they could possibly give you, and we're going to do it like that. It's going to be easy. Cake. And they can't give you anything harder than this. Okay? Ready? We're going to start with f of x is equal to x squared. Or let's even have more fun with it. Let's have more fun with it. I said the hardest thing we'd ever do, right? The hardest thing you could ever do. If you can do this, you can do anything. So 3x minus 4. Okay? Now, we're going to manipulate this parent function. We're going to manipulate this. Okay? And how we're going to manipulate it is we're going to do a horizontal shift left 5 and a vertical shift up 6. Okay? Well, let's not stop there, right? Because that's too easy. 2 things, that's too easy. Let's keep it going. How about also a horizontal stretch with a factor, and because it's a stretch, it has to be more than 1, right? So a factor of 7. But we can't stop there. No. We gotta make this hard. So let's do a vertical compression Is it still going? Good. Vertical compression. Now compression means with a factor of something smaller than 1, right? Compression. So 8/9. That's smaller than 1, right? 8/9. Notice how I used a different number every time. I want you to know where these numbers come from, right? There's a 3, there's a 2, there's a 4. So 2, 3, 4, 5, 6, 7, 8, 9. Right? All different numbers. So we know exactly where every number came from. Okay? Because it's not hard. This is not hard. What does horizontal mean? X what? We're talking about a function, so x, OPP, opposite. Okay? Very crucial now. What does shift mean? Plus. What is left? Negative. What is 5?
Probably 6.
Huh?
6.
5? It'd be 5. Smart ass. Alright? So, what is a plus and a minus? A negative, right? You have to remember that part, right? That is the hard part. Okay? So a plus and a minus make a minus. So x opposite of minus 5. What is opposite of minus 5? Plus 5. Yeah. Okay? So x plus 5. Okay. Whew. We did that part. That wasn't too hard figuring that out, right? Kind of makes sense? A little bit? Not even a little bit? Okay, remember, go back through it. Horizontal, x opposite. Shift is just a plus. So plus. Left, minus. 5 is a 5. And then plus minus makes a minus. And opposite of minus is plus. A little better? A little bit. Okay? All right, next one, vertical. When you see vertical, what should you see? F of x. Okay, I'm going to start with green. F of x. Actually, I'll do the same thing. I'll start with brown. We'll end with green. How about that? That'd be more better. F of x, the whole function. What does shift mean? Shift. Plus. Guys, focus. Right, Jordan? What's up? Are you writing any of this down, Jordan? Your paper looks clean, Jordan. You're gonna need this, Albie. This class will not be easy. You need to focus. Up. What does up mean? Addition. Up is positive, right? Up. It's a positive direction. Up. And then 6. What does plus mean? Plus. Okay? So 2 pluses make a plus. Okay? So f of x plus 6. All right, next. Horizontal stretch. What's horizontal mean? X opposite. Notice we keep doing the same thing over and over and over and over and over. Horizontal, x opposite. Vertical, f of x. Okay? What's the stretch, Jordan? Stretch. What does that mean? Not Saturday night? No, that does not mean not Saturday night. What does stretch mean? Stretch. Very good. Okay? Alright? And then a factor of 7 just means 7. So you're just taking, what's the opposite of multiplying by 7? Dividing by 7. Or multiplying by 1/7. I like to, you can do this. X divided by 7, right? But I'm just telling you, it's a lot easier if we get to this. Okay? So if you get to 1/7 x, right? It's the same thing, x divided by 7 and 1/7 x. Does everyone see that? They're the same thing? Okay? Alright, next. Vertical. Albie, what's vertical mean? Perfect, see? This is easy. Okay? Compression. Black, what does compression mean? Close? Multiplication. Remember, we try to keep it simple. Always multiplication. It is division in a sense, right? But when we're doing it, we're always multiplying by a factor less than 1, right? So it's actually multiplication, okay? Of a factor less than 1. In this case, it's 8/9, right? 8/9, which is 8/9. Good job. 8/9. All right. Now, what that means is I have 8/9 times f of x. Okay. Yay! We're done, right? No, not even close. But we're very close. Right?
Not even close, but we're very close.
Exactly. It's a conundrum. So, we're going to create a g of x out of this f of x. What I like to do is always space, parentheses, space, whatever this x is. In this case, it's 3x, right? Space, parentheses. Put the parent function here. In this case, the parent function is a... Yes, very good. 2. It's a square. Yes. I know this is hard. Okay? And then space minus 4. Okay? Because what we're doing is we're just rewriting this function right here, but we're going to do some stuff to it. Okay? We're going to manipulate it. What we're going to manipulate is, first we're going to add 5 to the x. So can I add 5 to x? Bam. Okay? Then we're going to add 6 to the function. So this whole function I'm going to add 6 to. What? Okay, that was hard. Then I'm going to multiply 1/7 times x. Oh, times this guy right here. So I'm just going to go 1/7 times that. I can do that. You know? And then finally, we're going to take the function, the whole function, and times 8/9. Notice I left the space everywhere for that orange, right? When I'm adding, it goes to the end. Or subtracting, it goes to the end. If I'm multiplying, it goes in the beginning. If it's the x, or if it's the function, it's ahead of everything. Now remember, this is to the whole function, right? So that means I need a little bit more here. I need that. Why do I need that then? What does that do? Why is that important? Because this is multiplying the whole function. Okay? Everything about the function. This whole function gets multiplied. Okay? Now, if it says that this comes after this, then so does this. Sorry. You see that? If it says that this function, right, this comes after this point, because it's going to tell you in what order. And usually it's going to say, okay, first we're going to do this. Second we're going to do this. Third we're going to do this. Fourth we're going to do this, right? Because this came after this, then this happens to that whole function. Does that make sense? To that whole thing. Okay? So, this is our new answer. This is the answer I'm looking for from you. Okay? Now you can come up with another one, and we'll talk about that. But today, this is all I'm looking for. And that's the hard part. Does that look pretty hard? Yeah, that looks pretty hard. That's no joke.